This lesson, let's study the intersection cases of a line and a circle. But before that, let's review the intersection cases of a parabola and a line. For example, let me draw the very basic parabolas. Y equals x squared, and let me draw it. It basically looks like this, a parabola. So I'll draw another straight line starting from point A. Let me just give a smaller steepness, smaller slope. As you can see from the graph, clearly they don't have any intersections. So here we can see they have 0 intersection points. But as I'm moving the straight line up, you can see somewhere they might have one intersection. And at this point, the yellow line is a tangent of the parabola. And if I go further, they will have 2 intersections. Well, even here, it looks like that they only have one intersection. But if I extend the parabola a little bit, they will have 2. So you see, further intersection cases between a straight line and a parabola, there will be 3 situations. They have 0 intersections, which means they will never meet each other. And they might have 1 intersection, which means the straight line could be its tangent. Or they will have 2 intersections, they have 2 points, they meet twice. And I could not only move the straight line up or down, I could also change its slope. You see, if I give it a greater slope, they might interact as well. So from point A, if it's a starting point, they could also have a tangent. They could also have a tangent. Or they could also interact twice. So that's the cases between a parabola and a straight line. So what about a reciprocal function? It can also have different intersection cases with the line. Let me just give you a basic reciprocal function y equals 1 over x, and let me just draw it. It's in the first and third quadrant. So still, I can give you a straight line. It goes like this way. So as you can see, starting from point A, they do not have any intersections. But if I move the straight line up for several units, you see it might be the tangent of the reciprocal function, which means they might have 1 intersection. And if I keep moving upward, they will have 2 intersections. Or otherwise, if I move it downward, they might touch each other somewhere, or it might intersect twice. So as you can see, the intersection cases between the straight line and a reciprocal function is also 3. They might have no intersections, they might never meet each other, or they might have 1 intersection, which means they touch each other, and they might also have 2 intersections, they might meet twice. So it's the same with the circle. For example, I could draw a circle here. And there's also a line starting from point A. So you can see when I'm drawing this pink line, clearly from the graph, they have no intersection. But still, if I move the pink line a little bit, they might touch each other. They might just have 1 intersection. And if I move it more units down, they will have 2 intersections until they touch again. And then if I keep moving, they will not meet each other again. So it's the same with a circle. They might have no intersection, or 1 or 2. And let's get into a problem. So given you a equation of a circle, so x squared plus y plus 2 squared equals 29. And also a straight line, y equals x plus 5. So do they have intersections? If they have, do they have 0 or 1 or 2? And what's the coordinates of their intersections? So first, let's draw the graph of a circle. Based on the radius center formula, you should read its center, which is O minus 2. So this is center. And its radius will be 29 to the power of 1/2. So this is its radius. Let me draw this circle here. This is a circle. And for the straight line, it's y equals x plus 5. Let me just make the radius looking bigger. Yeah, this is a circle. And let me draw the straight line. It might look like this, or they look like they interact, but I'm not sure about it because it might look like this or this. I'm just roughly putting it here. So let's just suppose and assume that they have two intersections. If they don't have, we might not find any solutions if we solve them together, but let's just suppose they have. And still, because point A and point B lie not only on the circle, but on the line as well. So they must satisfy each other. So for the equation of the circle and for the equation of the line, they're a set of simultaneous equations, which means they share the same value x and y. So I can substitute the y into the first equation to solve it, to try to solve if they have intersections or not. And let me try to do that. So it's x squared plus x plus 5 plus 2 squared equal 29. And then I could expand the brackets out. X squared plus 14x plus 49 equals 29. And rearrange them, it would be x squared plus 7x plus 10 is 0. And by the way, normally a calculator is allowed when you're taking an exam, but in daily exercise, I still recommend you to do it by hand because it can exercise your counting ability. Well, if you use computer, it's just okay, or you can use a quadratic formula. But anyways, you can work out the value of the root, which is x1 is minus 2, or x2 is minus 5. So it means that the pink line I draw is a bit flawed. It should be looking like this. And they have two intersections, A and B. The coordinates of B is minus 2, and in order to get its y coordinates, I can substitute it back into the straight line, or the circle is also fine, but I think the straight line is easier. So when I substitute it back, I can get the y coordinate is 3. And for A, its x coordinate is minus 5. So its y coordinate could be 0. Oh, so this line is also flawed. I could rearrange it. Let me just take it in the right way. Oh yeah, this looks perfect. This is point A, so it's minus 5, 0, and this is point B, minus 2, 3. And this is how they interact. So it still goes the same way as finding the intersections between a parabola and a straight line. You just need to combine them and solve a set of simultaneous equations, and then substitute the value back to get the coordinates of their intersections. So it's still the same. So what if they do not interact with each other? How do you prove they have no intersections? How do you prove they never meet? Let me just give you another classic problem. So given your straight line y equals x minus 7 and a circle x plus 2 squared plus y squared is 33, and prove them they will not meet each other, they will have no intersection. Well, first you can, but you know graphs can lie to you because it might not be with high accuracy, so they might lie to you. But let me just still try to draw the graph here. So the center is minus 2, 0, and the radius is 33 to the power of 1/2. So it basically looks like this with a bigger circle because its radius is bigger than 5, so it goes like this. And for the straight line, y equals x minus 7. let me do it like in this way. Since the problem is trying to let me prove they have no intersection, let me just draw it as they have no intersection. I'm not sure, but let me just make it go like this. So how do I prove it? You cannot just draw a graph and say that, hey, you see clearly they do not interact with each other and that will be it. You cannot do that because your hand is not accurate. Unless it's a computer, but unfortunately you're forbidden to use a computer. You're only allowed to use a calculator. So how to prove this? Well, the thought is still quite easy. First, we assume that they intersect. We assume there are no matter one or two intersections, but anyways, we suppose that they will meet each other. And then we're trying to find the coordinates of their intersections. So we can try to solve both of the equations. We can try to solve them. If they do interact with each other, we can find solutions of the equation. So we can substitute the value of y into the first equation. And let me try to do it. I'll use another pen. So it's x plus 2 squared plus x minus 7 squared equals 33. And let me just expand the brackets out. It will be x squared plus 4x plus 4 plus x squared minus 14x plus 49, which is 34. And rearrange them, simplify it, it will be x squared minus 5x plus 10 equals 0. So do these equations have roots? We can use this discriminant to tell. So it's discriminant b squared minus 4ac. So b is negative 5 and a is 1, c is 10. So it's minus 4 times 10 times 1. As you can see, the discriminant is smaller than 0, which means these equations have no real roots. And it can be concluded that they do not meet each other actually. So if they do meet each other, from algebra, we can definitely find 2 or 1 root, but we cannot find any real root. So it means that they do not interact. And then that's how it's proved. So let me just get it straight. First, you suppose them having intersections, and then you're trying to solve to find the coordinates of their intersections, but as a result, you cannot find it, which conversely proves that they do not meet each other.